Hi guys, welcome to this channel. Today in this video, I will guide you on how to find the integrals giving inverse trigonometric functions. Meaning, when we integrate, it gives us the result of inverse trigonometric functions. As you can see, we have three formulas here, and these formulas are the formulas that we are going to use for finding the integrals giving inverse trigonometric functions. So, first, we have the integral of du over the square root of a squared minus u squared is equal to arcsine u over a plus c. Second formula is the integral of du over a squared plus u squared is equal to 1 over a arctangent u over a plus c. The third formula is the integral of du over u square root of u squared minus a squared is equal to 1 over a arcsecant u over a plus c. These formulas for integral are derived from the formulas for the derivatives of inverse trigonometric functions, meaning each of these formulas were derived from its derivatives of inverse trigonometric functions. So say, for example, in this first formula of arcsine, we have the derivative of it. So, as you can see, we have the derivative of the inverse trigonometric function of sine to demonstrate that this formula is derived from this formula. Derivative of arcsine, which is d over dx, arcsine u is equal to du over the square root of 1 minus u squared. So as you observe, the 1 here is substituted by a squared, right? And only the u squared and du is copied. So that's it. Same as with the second formula and third formula. And as you notice, we only have three inverse trigonometric functions here. We didn't include the other three, which are the cosine, cotangent, and cosecant, because they are essentially the same but have negative sign. So meaning that with the same formula, it has a negative sign here for our cosine, as well as for our cotangent, it has negative sign. Also for our cosecant, it has also a negative sign. So as you can see, the other three formulas that haven't mentioned has the same formula but differs in the signs. To have a better understanding, I will provide some examples to illustrate this formula. Let us now evaluate the following integrals. So let's work on the first equation. In our first equation, we have the integral of dx over the square root of 16 minus x squared. The formula that are we going to use is the first formula, which is the integral of du over the square root of a squared minus u squared is equal to arcsine u over a plus c. So let's write the given. Okay, our a squared is 16, and then our u squared is x squared. Let's square root both sides to get a is equal to 4, and then u is equal to x. Our du is dx. Using this formula, let's substitute this given. Is equal to integral of, our du is dx, square root of, our a is 4. 4 squared minus our u is x, so x squared is equal to arcsine. Our u is x over 4 plus c. So here it is. So here's the answer. That's how we are going to find the integral giving inverse trigonometric function. And now let's work on the second equation. Our second equation, we have the integral of 3 dx over 25 plus x squared. So since it has an addition here, the formula that we are going to use is the second formula. The integral of du over a squared plus u squared is equal to 1 over a arctan times u over a plus c. So we're going to write the given. Our a squared is 25, and then our u squared is x squared. we're going to square root both sides to get a is equal to 5, and then u is equal to x. Our du here is 3dx. The next step is to substitute this given into this formula. Is equal to, let's move 3 in front so that it will become 3 integral of dx. Our a is 5, right? So over 5 is squared plus our u is x, so x squared is equal to 1 over a tan arctan, then u over a plus c. So let's substitute the given here. So our a is 5. Our u is x. Since we have 3 here, let us put 3 here, and then 3 times 1 is 3, so that it will become 3/5 now. So here is the final answer. That's how we get the integral for the arctan. And for our third equation, try to evaluate this integral. Let us now discuss the additional formulas of integration. So we're going to discuss two formulas of this topic. Okay, first we have the integral of du over u squared minus a squared is equal to 1 over 2a ln the absolute value of u minus a over u plus a plus c. And then the second formula is the integral of du over a squared minus u squared is equal to 1 over 2a ln the absolute value of a plus q over a minus q plus c. So as you have observed that we just replace this, right? So u squared becomes a squared here, and then a squared becomes u squared here. Then copy 1 over 2a ln, and then the bottom expression here is now here on top. We substitute u by a and then a by u. The negative expression here become the negative expression on the bottom of this formula. Okay, for a better understanding, let us evaluate these two integrals. So let us begin with our first integral. Okay, what did you observe from this integral? As what we observed, the constant here is in the right side and the expression here is in the left side. So what formula are we going to use? It is the first formula, which is the integral of du over u squared minus a squared and so on. So take note that our a is constant. So that's why our u squared is this, or a squared is this. Now that we identify what formula that we are going to use, let us follow this formula. But first, let us write the given. So we're going to let u be x minus 3, and then the derivative of u is dx. Our a squared is 25, so we put 25, and then if we square it both sides, it gives us a is equal to 5. So let us now substitute this here in this formula. So our du is dx, so we put dx here. And then our u is x minus 3, so x minus 3 is squared. And then our a is 5, so 5 is squared. So now, we're going to follow this. So 1 over 2, our a is 5, so 1 over 2 times 5. And then ln, our u is x minus 3 minus 5, and then over x minus 3 plus 5, copy c. So now, we're going to simplify this. So 1 over 2 times 5 is equal to 1 over 10. Then in, and then x minus 3 minus 5 is equal to x minus 8 over x minus 3 plus 5 is equal to x plus 2. So that's it. And then copy c. So now this is our final result. That's how we are going to evaluate this integral. Let us now move on to the second integral. Okay, let us now solve integral of dx over 49 minus 25x squared. So what did you observe from this form? We observed that the constant is now in the left side and the expression is in the right side now, right? So what formula are we going to use in order to evaluate this integral? We're going to use the second formula, This because our A, as what I've said, A represents constant. Our A squared is 49 and then our U squared is 25x squared. So now we're going to follow this formula. Okay, but first things first, we're going to write the given. Let U squared be 25x squared. If we square both sides, it gives us U is equal to 5x. And then the derivative of U is 5dx, right? So when we divide both sides by 5, it gives us du over 5, which is now our dx. And then our A squared is 49. So we're going to put 49 here, and then if we square it both sides, it gives us A is equal to 7. So this given that I have circled is what we are going to substitute here in this formula. So let us now substitute. Let us begin here. So our du here is 5dx. So we're going to put integral of 5dx over our A is 7. So we're going to put 7 squared. And then our u is 5x. So 5x squared is equal to 1 over 2. Our A is 7. So 7 ln absolute value of 7 plus 5x. And then 7 minus 5x. Copy C. So now we're going to simplify this. Let us move 5 here in front. So it gives us 1/5. The integral of dx over 7 squared 5x squared. 1 over 2 times 7 is equal to 14. And then 1 over 14 times 1/5 is equal to 1 over 70. And then copy ln. We cannot simplify this now. So we're going to copy na lang x plus c. So the answer is here. Okay. This is the final answer. That's how we evaluate this integral using the additional formula of integration. Let us now discuss how to evaluate improper integrals. So what are improper integrals? Improper integrals are definite integral with limits of integration as negative infinity on lower limit or positive infinity on upper limit, or both. We will solve some examples on how to evaluate improper integrals. As you can see, we have 3 formulas here. These formulas will be used on evaluating improper integrals. So, first we have the integral of f of x dx from a to positive infinity is equal to the limit of integral of f of x dx from a to b as b approaches positive infinity. For our second formula, we have the integral of f of x dx from negative infinity to b is equal to the limit of integral of f of x dx from a to b as a approaches negative infinity. And for our third formula, we have the integral of f of x dx from negative infinity to positive infinity is equal to the limit of integral of f of x dx from a to b as a approaches negative infinity, or it can be the limit of integral of f of x dx from a to b as b approaches positive infinity. So you should remember these formulas when evaluating improper integrals. And when we are evaluating an improper integral and we do get a finite number as an answer, then we can say the interval is convergent, meaning if the limit exists. Otherwise, when we get an infinity as our answer or as the result, then the interval is divergent, meaning the limit doesn't exist. So let us solve some examples to illustrate these formulas. for better understanding. Let us now evaluate the following improper integrals. So let's work on the first equation. Okay, in our first example, we have the integral of 1 over the quantity of 3x plus 1 squared dx from 1 to positive infinity. So as you observe, our upper limit is positive infinity, and then our lower limit is a constant, which is 1. So from this form, the formula that we are going to use is the first formula, right? It is because the lower limit is a constant and then the upper limit is positive infinity. So this formula is what we are going to use in evaluating this improper integral. Okay, so let us rewrite this. Lim b approaches to positive infinity, then integral. Our a is 1, so 1. Let's replace positive infinity by b, so, and then our f of x is 1 over the quantity of 3x plus 1 squared. Then copy the dx. Okay, we're going to let u be 3x plus 1. And then the derivative of u is 3 dx. So if we're going to divide both sides, it gives us, so our dx is du over 3. Okay, the next thing is to copy the integral 1 over, since our 3x plus 1 is u, let us replace it by its variable. So it is u and then copy squared. Our dx is du over 3, so write du over 3 here. And then let us move 3 in front, and then it gives us 1/3. Integral of this expression can be reversed, or the inverse of 1 over u squared is u raised to the power of -2, right? Using the power rule, we're going to add it by 1. So u raised to the power of -2 plus 1 is -1. So same as our denominator. So it gives us -1. And the du here, we put it right beside of this expression. The next thing is to copy 1/3, and then let us move -1 on the top and to the top, and then let us u raised to the power of -1 to the bottom. So it gives us -1 over u. So the next thing is we multiply this 2. So it gives us 1 times -2 is -1, and then 3 times u is equal to 3 plus c. So let us substitute u by its value, which is 3x plus 1. So 3 times 3x plus 1, and then copy c. Let us now apply this. So the limit as b approaches infinity. So let us just copy the expression here. So -1 over 3 times 3, the quantity of 3x plus 1. And then let us evaluate from 1 to b. So since we have this 1 and b, okay, let us evaluate this. This upper and lower limit will become the substitute or the replace for x. So -1 over 3, and then 3, our x is b, so b, and then 1. Minus, same as with, same here, so -1 over 3, the quantity of 3, our x is 1, so 3 times 1 plus 1. So let us simplify this, okay? So -1 over 3 times 3b is equal to 9b. 3 times 1 is equal to 3. So 9b plus 3. And then copy -1 over 3 times 1 is equal to 3 plus 1 is equal to 4. So 3 times 4 is equal to 12. The limit of -1 over 9b plus 3 as b approaches to infinity gives us 0. And then the limit of -1 over 12 as b approaches infinity is 1 over 12, right? So 0 plus 1 over 12 is equal to 1 over 12. This is finite result or finite value, which means that this is convergent, meaning the limit exists. In our second example, we have the integral of dx over the quantity of 4 minus x squared from negative infinity to positive 2. So as you observe, our upper limit is a constant, and then our lower limit is a negative infinity. So in this form, we are going to use the second formula, which is the integral of f of x dx from negative infinity to b is equal to the limit of integral of f of x dx from a to b, where a approaches negative infinity, right? So, same as with our first example, let us rewrite this. Limit where a approaches to negative infinity. And then copy our constant, which is 2. And then let us replace negative infinity by a. Our f of x is dx over the quantity of 4 negative 4 minus x squared. So, okay, the next step is to write the value. So we're going to let u be 4 minus x. So 4 minus x, and then the derivative of u is negative dx, and then when we divide both sides by negative 1, it gives us negative du, which is our dx. So here, we're going to copy the integral, and then since our dx is negative du, we write this on top over, let us 4 minus x substituted or replaced by its variable, which is u. So let us write u and then squared. Okay, let us move this negative sign in front, so it will become negative. The integral of the inverse of 1 over u squared is u raised to the power of negative 2, right? So the du here, let us put right beside this expression. And then the integral of u raised to negative 2 is copy the negative sign, and then let us do the power rule. So u raised to the power of negative 2 plus 1. Same as with the denominator, let us copy this exponent. So negative 2 plus 1. So when we simplify it, it gives us the negative u raised to the power of negative 1 over negative 1. So let us cancel the negative sign here so that it gives us u over negative 1. So this expression can be inverse, right, or can be reversed. So it gives us 1 over u. And then the value of u is 4 minus x. So we replace it by its value. And then the next thing here is to apply this. So we're going to apply this, and then let us just copy this expression. So 1 over 4 minus x, and then let us evaluate from a to 2. So a and 2. The upper limit and the lower limit will become the substitute for x. So 1 over 4 minus 2, no? And then minus 1 over 4 minus a. We then simplify it. So 1 over 4 minus 2 is equal to 2. So it will become 1 half is equal to 1 over 4 minus a. So here. And then the limit of 1 half as a approaches to negative infinity is 1 half. And then the limit of 1 over 4 minus a as a approaches to negative infinity, it gives us 0. 1 half minus 0 is equal to 1 half. So as what I have said, right, that when we get a finite value or finite result, it is then called a convergent, which means that the limit exists. So I hope you understand our lessons for today, and may this help you in evaluating such integrals.